on the other side, which I haven't put down at the minute, but doesn't matter too much. So
yeah, it doesn't matter too much. Have you got your slide deck up? It's probably worth if we just run off of that, mate, because then we can both keep track as to where we were.
I'll just get the tea I made in the kitchen.
Yeah, go do your stuff, buddy. Go do your stuff. Yeah. And this is the real world of podcasting. You just go online, you turn up, and you just wing gracefully, because it's now Friday, Saturday, or Sunday night. I don't even remember what day it is, and we just chat as pals, and it ends up being this podcast. So, cue the intro. Hello, everybody, and welcome to these extra special E5 podcasts. I am your host, Paul Meenan, and I'm joined by a dear friend. Introduce yourself.
Hello, I'm JW.
JW, thank you very much for joining me on this. So these are these special edition podcasts, I suppose. We've had, it's the end of a week. It's Sunday night. I think it is Sunday night. It's Sunday night, isn't it? Yeah. So we are recording these late at night because this time last week we were preparing ourselves for a midnight Monday morning release of the 18th edition Amendment 2, and it didn't get released till around noon-ish. So myself, yourself, and Mr. Ninja, who may jump in at any time on this podcast, had to wade our way through treacle. And that's worth noting. Everything we're going to talk about in these podcasts, because we probably won't get it covered in an hour, is proposed. It's a draft for public comment, which means anyone in the public can have a view.
Yeah, these things are put out specifically for people to comment on them. So if you do want to comment on it, make use of the opportunity. You've got until mid-December. I think it's the 11th of December. And there are a lot of changes, but a lot of them are quite minor and fairly insignificant. But we'll try and stick to the major and more important items.
Yeah, there are. There's a lot of key. We were quite blown away, actually. Now, the annoying thing is, and I'm going to start straight away because I know people who sit on the JPL committees listen to these. A bitter disappointment in the way, not only the mechanism of the BSI website, but the difficulty in the challenges you've given people in trying to understand the changes.
Yes, I mean they have made one change since it was put out. They put it out on a single document originally, which was hideously slow.
Yep.
And they've now cut it up into 4 bits and put them out individually, which is slightly better because there's a bit quicker for each one, but it's still the same kind of
but even some of those ones that they put out separately were difficult to access as well, though, weren't they, John?
Yeah,
it was a bit of a farce.
This weird sort of scrolly thing, and you can only view a bit of it at a time and all that. But anyway, that's what they've chosen to do. So
yeah, right. So anyway, Amendment 2, draft for public comment. It is planned for release on the 28th of March 2022, which means in 2022, which will come around pretty quick, you can start using it. And then it's got a 12-month implementation date of 28th of March 2023. The draft for public comment, the commenting stage, I believe, John, is the 11th of December. Comments close.
Yeah, that's the date they've got on there at the moment.
So we've got we've got a healthy 2.5 months to comment on it, which is nice. 12 weeks, I think it is. So yeah, so anyone who's listening to this who feels like they want to comment, if you go onto the BSI website or even the ECA website's got a great example of how to comment. Make sure your comments are succinct, polite, so short and quick. Quote the regulation that you've got an issue with, give your reasons, and then maybe quote a reworded or revised version, because they tend to not delete the regs, probably because they're not very good at listening to the industry. But there you go. It's just my personal opinion. But yeah, so there you go. 2022 will come around pretty darn quick. And I don't expect, John, I expect maybe 40 or 50% of what we're going to talk about in these podcasts to actually make it. It's the same as the 18th. Remember when the 18th had a whole section on energy efficiency, and that all just got butchered and chopped? And
yeah, that particular bit would actually have benefited if they'd put it in this one, because a lot of what's in that is actually referred to from the new Part 8. And instead of saying, look in Chapter 81, it says go and look at the other standard, which you have to pay 200 quid for. So not over
100 plus of the Queen's pounds. It's a bit ridiculous, really. Right, let's get started then. So let's get into the first regulation. So there's a new, just for everyone very quickly, when the 18th edition came out, there was a lot of people who were sharing it online. So there's a new website now, and that's just to raise awareness of fakes, because the last thing you want to do is use a fake PDF in your selection direction, and if you then make a mistake, you're screwed. Simple as that. So http electrical.theiet.org/BS7671/fake awareness. There is a new website. I haven't actually visited it yet. I don't even know it's running, but there is a new website that apparently will give you more awareness. Before we start, I just want to remind people on page 2, there's a note that states compliance with this British standard cannot confer immunity from legal obligations. So you need to use your own skill and judgment when making use of it. Now, part 1, and this got a lot of laughs, to be honest with you. Regulation 110.1.1, where it's the list of items that are included within the scope of 7671. Domestic now has the term dwellings next to residential premises.
Yes, this is a good one. So now we can have, instead of domestic installer, we can have dwellings installer instead. So,
are you a dwelling installer, John?
No, I'm not. I do work in domestic things, but yeah, this thing with dwellings, it's quite an odd thing to put in there. It's probably because it's referred to that in certain other countries, and they've decided to sort of align it with everything else, which is where a lot of these things come from.
Yeah. So 1101 part 1, which is the first. Literally after the first line, the regulations apply to the design, erection and verification of electrical installations, such as those of, it then says residential premises, and the new term dwellings. So we used to call it domestic, and you'll see in part 6, they've removed or proposed to remove the word domestic and just replace dwellings. So all those NIC, EIC domestic installers, I'm not going to snigger much when you change your badges to dwelling installer, which I think is just a very strange term. But then again, I've grown up with domestic, commercial, industrial, and that's quite a major change to the mindset of people in the industry, really.
Yeah, it's not quite change for the sake of change, but it's sort of
alignment, isn't it?
Yes.
Yeah. God love European harmonisation, and the fact that we all voted Brexit, or most people voted Brexit, and that seems to be completely ignored by the British Standards and Institute. But there you go.
Yep. That's, regardless of us leaving the European Union, all of these standards and everything will still come from the European harmonised documents and Senelec and whatever. So that hasn't changed in the slightest, and it's going to be just the same whether we've left or not. So
can I confess something, John? When I voted for Brexit, which I'm not ashamed to say I did admit, one of my reasons was actually the hope that we would stop this harmonisation to the point where we were lowering our own standards. Because many years ago, the British standards were the highest in the world. And now we seem to have used technology to mitigate and allow skills to be lowered. And that's, I'm not happy with it, to be honest with you. If I voted legally to leave the EU and all their rules and regulations, why has the British Standards Institute seen fit the day after Brexit to announce we're going to continue regardless? How is that legally allowed?
Exactly. And then the other weird thing is that the European standards have a lot more in them than ours do, because they sort of pick and choose bits and then put them in, like the new Part 8, which we'll look at probably a later episode. But anyway, shall we move on to the next
go for it.
then?
Go on.
So the next one, this is 110.1.2, and this is the scope, and this actually adds installation and support of fiber optic cables. So this is something that's not been in there before, and fiber optic cables are now included. So this would include things like you're going to fix them up with fire resistant fixings and not have them dropping down over the walkways and things when there's people trying to evacuate the building. I think this is a useful addition.
I think it just adds clarity and removes confusion to the whole premature collapse regulation, which is still a piece of debate. And I'm looking forward to when we're 5 years down the line with this, where people have it's become normalized that premature collapse is a consideration. Because that's the thing, when you're an electrician, over the years, you have to consider selection and erection when new regulations come out, and how do these regulations impact your decision-making process. So for me, this is only a good thing.
So data cable installers, you can't just lash things in above the ceiling with no support, and shouldn't be doing that anyway. And
Yeah.
fiber
No
optic
more.
stuff now is part of
No
it.
more Indiana Jones. None of that yeehaw, yahoo stuff over a suspended ceiling. Although they'll do it if they want to anyway. But interesting point, I did make this on the podcast, was obviously within the scope of BS 7671, it does actually cover 11012 Note 5, fixed wiring for information and communications technology, signaling control cable, and including fiber optics. So most telecoms installers, do we get minor works or electrical installation certificates just to cover that cabling, the installation of it? It'd be interesting to ask people who do the purist comms stuff. I have asked of my comms installers for an electrical installation certificate, so they declare they have met the requirements for premature collapse and any other requirements of the regulations. So, interesting one to ask your installers. Anyway, moving on. Regulation 1312.1, which is it's a sad day. I think it is, John. And it's what it is. It's in the 18th edition. There is a note which talks about basic protection being protection against direct shock, and that has now been removed. So it's gone. No more notes about protection against direct shock. So it's just basic or fault protection now.
Yeah, the actual intent of this hasn't actually changed. It's just more about which words they're going to use to describe this. So it's if you're used to the old terms in there, then unfortunately they have gone. So, or at least will be going.
So yeah, those of an older age. Regulation 13121 and 321 spoke about basic protection being protection against direct shock, and 13122 spoke about LV fault protection being protection against indirect shock. So those who are of a certain age, I include myself in that, when we were in college, we learnt that basic and fault protection was protection against direct and indirect shock. That's now gone from the regulations. So those references are gone. So now it's just sparky talk, basic and fault, whereas direct and indirect is probably easier for the layman's and explaining it to the non-technical people. I don't think there's any rules against you not using those terms still, but I think they'll fade away over time.
Yeah, now they're not in there, and not any of the colleges or whatever won't, or hopefully won't be using those in their new training material. So if you've used them before, you're going to keep them, but if not, then it's going to be new people are not going to be taught those terms anymore. So.
Yeah, indeed. Right, so moving on, that was kind of really it. We were expecting a lot more for part one because, John, we know from our research that part one, there is plans to pretty much rewrite it and overhaul it quite a lot.
Yeah, they didn't change much. I mean, there were some other changes there, but a lot of it was things like it's now capitals instead of lowercase and all of that bother, which really doesn't change anybody, does it? So, and a couple of like changing the odd word here and there on some of them, but reality, they seem to like putting those in for reasons just to make it look as if they've done more work, presumably.
Yeah, well, let's not get onto the spelling, grammar, typos, and all the errors that are in the regulations that never got fixed during I don't think I've ever seen a copy of the regs where there hasn't been an error, omission, or mistake.
Yeah.
Ever in my entire career. Just get used to it, guys. It's not a perfect document. It's a basic document you work from, not to. Part two. Let's just skip over. Let's go straight to part two, shall we, John?
Yeah, part two, definitions. There's a lot of new ones. Mainly because there's a lot of new stuff further on which these apply to. So, we'll have a look at some of them.
Well, let's quickly skim through these because part two there's quite a lot of changes. So in part two, just to give you an example, there is terms called efficiency measures, emergency switching off, foundation earth, electrodal cover, generating set, load shedding, metering, protected escape route, switch, efficiency measures, operating mode, prosumer's electrical installation, reverse feeding mode, rural environment, suburban environment, urban environment, and EEMS are all defined. Now we'll cover them on the journey of these podcasts, but one of the quick ones I want to go through: consumer unit redefined. So consumer unit, John, was, and I'll read out the definition in the current edition of the regs, a particular type of distribution board comprising a type tested coordinated assembly, which means don't mix and match breakers, folk, for the control and distribution of electrical energy, principally in domestic premises, incorporating manual means of double pole isolation on the incoming circuit or circuits, and an assembly of one or more fuses, circuit breakers, residual current operated devices, or signaling and other devices proven during the type test of the assembly as suitable for such use. So that's a very robust way of saying single manufacturer, don't mix and match, double pile isolation's your key part here, and domestic premises. That's changed, John.
Yeah, we've now got a particular type of distribution board intended for operation by ordinary persons, whatever they might be. So
I don't know what they are.
And the rest of it does go on. It's fairly similar to before with the double pole and all that other stuff. But yeah, operation by ordinary persons is kind of the key point there.
What is an ordinary person exactly? Do we know what it is?
I think it is defined further on.
Oh, yeah, here we go. A person who is neither skilled nor instructed. So that's basically everybody, the general public. So a distribution board intended for operation by the general public, compromising a type-tested coordinated assembly, right, incorporating manual means double pole on the incoming circuits and or assembly by one or more protective devices. John, have you noticed what's disappeared from this? They have sneakily removed the term fuses.
Yeah, so our fuse is no longer valid. That's a bit of a sad day if that is the case.
Well, according to this, an assembly of one or more protective devices signaling and other devices. You could argue, and I think people have been debating it on social media, does this new definition of the consumer unit mean that certain boards of a certain age are now no longer compliant?
Yes, the Wilex 3036 or BS336 boards with the rewirable fuses in.
I wonder if they're in this version, if this document still. They probably still are, because nothing ever disappears overnight. But I'm sure that it's kind of signaling the beginning of the end, if that makes any sense.
I mean, to be fair, 3036 fuses are not something you're ever going to use now, and they should have probably gone away quite a long time ago. But of course, there are other types of fuses. Yeah, they're still mentioned in the.
Yeah, they are. They're still in the regs.
So they still exist. But yeah, interesting they've taken it away from that particular definition. So
it is indeed. So one other thing that's incredibly interesting is we were, I'm just going to throw my arm up and go, yay. We were absolutely bang on right with our many hours of research. The consumer of electricity and the producer of electricity is now defined as a consumer or a prosumer, which is nice to see, because if anybody's watched our Future of the Wine Regs, or they went to Alex last year at Sandown, I think it was, where we did a little talk where we kind of guessed after many hours of research where the future of the industry was going. So it's nice to see that we're not demented and our research is correct. But then again, it's not just our research. Anyone can do this. All you've got to do is be able to find the BSEN standards, know they exist, and then obviously make sure you have access to them via a bit. I'm lucky I have a account access, which is good. So I can read them, but to buy them individually, it's, again, I suppose it takes on to the debate of the criminality behind putting safety standards behind a paywall, because I think it's criminal and it's morally and socially reprehensible to not allow people who use the standards to access them.
Yeah, and paywall, as in if you buy the standards individually, you're looking at typically hundreds of pounds each. And when you've got to look at, say, 40, 50 or more of them, then obviously it just gets into ridiculous territory and people just don't bother, because who wants to spend 20 grand on a load of standards? So.
Yeah, I know. Tell me about it. So there is a new mode called connected mode, which is an operating mode which needs connection to the public network, which infers direct and reverse feeding mode. Now, this is very simply put as a car, which you can plug in and charge, but also could be used to run your home as well. This is it's another step we're taking towards the prosumer, and realizing that the grid itself, the grid has to change, doesn't it? It's fairly evident the grid has to change. This is just one of the methods that it is going to change on.
Well, the thing about the grid is it already is changing, and this smart grid thing has actually been going on for several years already. without people
Yes.
being told about it in any less detail. So
Yep.
all of this stuff in this new bit, which we'll do later, it's not some future way off thing that's going to happen in 5-10 years time. It's already happening today, and it's actually already been happening for several years already. So we're already well down that path, and for some reason we're only now just seeing the stuff showing up in things like this particular standard.
And you're absolutely right, John. I mean, I found out about the DSO, which I'll come on to a second, years ago. Literally about 4 or 5 years ago, I wrote an article, I think, on LinkedIn, which introduced people to the term, and everyone's like, never heard of it. But there's so much goes on in our industry. You can see there is a strategic direction set by government and various high up organisations that take many years to filter down. And you can see where we're going with the grid, because the grid's so old, it's never going to get replaced. So eventually, I can see in 50 to 100 years, our national grid being a local grid.
Yeah, I think it's inevitable. And I saw a video the other day, which was from the Energy Networks Association, or the ENA, which is sort of all of the DNO sort of combined sort of mouthpiece of the industry sort of thing. And it's quite short. It basically describes what the smart grid is and what's happening about it. And it's on YouTube. You can see it for free and everything. And the interesting thing about this video, it was put out nearly 2 years ago. So this is not a new thing at all. And it only had about 1,000 views, which proves that nobody looked at it and nobody cares. But yeah, it's all here.
Mm-hmm.
And this particular definition, when you're in this connected mode, it's where your house is connected to the grid, but it's not just about you taking energy in from the grid, it's about you can put energy back into the grid and obviously therefore support the rest of the system, so your solar panels or your electric vehicle.
And that's the thing. That's the thing, John. For those listening, if you put this into the context of the practical, imagine you're on a cul-de-sac, and there's, say, 10 houses. Each one of them houses has an electric vehicle charging point. Each one of them houses has, say, an 8 kilowatt array, solar PV, and they've got ground source heat pumps and various other bits and bobs. That street will take some power off of the national grid, but if all them 12 houses then, for instance, they then have Tesla walls fitted, and they all have electric vehicle chargers, then there shouldn't be any reason why they can't go off grid, given the so little that we consume nowadays in our homes.
Yeah, that's right. And this brings us on to the other definition, which is island mode, whereby if you're disconnected from the grid, all your lights and things stay on because you're running off of your local storage, or electric vehicle battery or whatever else, compared to what you normally get at the moment if you've got a solar system. If your power goes away or the grid goes away with your current solar installation, the very next thing that happens is your solar inverter shuts down and you have no electricity, which is done from a safety point of view. However, it doesn't make a lot of sense economically, because if you've got all that power you're generating, why shouldn't you be able to continue using it in your house? It's there for the using. So that's island mode. So just
island mode. Island mode's an interesting one, because for contractors, John, a lot of people are going to be ringing up contractors in a few years' time and saying, I've got a solar PV array and it switches off when I get power cuts, and I get power cuts regularly. Make it stop. Yeah. So contractors are now going to want to understand island mode and what they need to do to contribute towards creating an island mode for an electrical installation, and how they can allow people to actually benefit from the energy they're producing safely, of course.
Yeah, safety is of course important, and that is covered in the part 8 as well. But yeah, it's again a completely different way of thinking about this stuff, so that you can basically keep your things running permanently regardless of whether there's a grid power available or not.
Yes, indeed. 2 other little ones. Direct lightning strike is defined now, which is lightning strike impacting a component of the network directly. Examples of components of networks are conductors, towers, substations, and equipment. There's a note that then also says consequences of a direct lightning strike include the thermal, magnetic, and mechanical effects of the discharge, as well as the surges relating from its volt drop along the discharge path. So there's some interesting definitions. And of course, they've also defined stroke, because this was talked about in the 18th edition, but they forgot to stick it in. I'm going to assume it was forgotten to be stuck in. So indirect lightning stroke is the one that most electricians have to deal with, which is a lightning strike that does not impact directly any part of the network, but does induce an overvoltage in that network. There's a note that then says consequences of an indirect lightning stroke for an electrical installation are associated overvoltages and the energy content of the incoming surge wave. I think the best way of explaining this is if you've got a street and there's a substation down the road from you, a lightning strike goes and hits the ground, it will make the after effects of that lightning strike may cause a rise in voltage on those old cables buried in the street, which is where that surge arrestor is so critical for your domestic installation, because your domestic installation only looks for thermal protection and magnetic protection and earth leakage. It doesn't look for overvoltage. So maybe time to stop arguing about whether we do it and just do it.
Yeah, this is where you can think of it like if it strikes if you had a lake and you threw a big rock in the middle of the lake, you're going to get big ripples going out in every direction. That's the same kind of thing here. So your lightning strikes the ground somewhere. That energy doesn't just disappear into a little hole in the middle. It spreads out across everywhere, in some cases up to a mile or 2 miles out. And therefore anything in that area could end up with an elevated voltage and damage to equipment.
Yeah, which we're seeing more and more of, aren't we, John, now, thanks to social media. People are able to share the photos of the call-outs they're going on, and the lightning strike statistics are going up and up and up in this country because the weather patterns are changing.
Yeah, and I think it's important to realise that even in a typical, say, storm that lasts for like 20 minutes, you can typically have thousands of lightning strikes and strokes. So it's not just the odd one or two that you might see out your window. There's huge numbers of these things. So damage to electrical equipment is something that happens pretty often. Unfortunately, most of it's not reported as that because it's like, oh, my TV stopped working, it must be too old, it must be broken, just buy a new one. When in fact, it could well have been caused by an overvoltage event. So, of course, unless you're going to sort of forensically dismantle all your equipment and have it sent off to a laboratory for that, then you're never going to know the exact cause. But overvoltage is a very, very likely cause.
Yeah, and I think in time what you'll find is areas where this is common, the local electricians will be able to see it once surge protections are installed on a bigger level, because they'll be failing more and there'll be more call outs. So in 10-15 years time, the impact of surge protection being in the wiring regs will now become one of those things where guys are not called out to just a faulty RCD but a blown cartridge in an SPD device, and they'll be then say this area is actually quite rife for lightning strikes of last year. So we'll be able to get some data to understand the benefits of it in time.
Yeah, surge protection though, I mean it's pretty much mandatory everywhere anyhow if you look in the actual current regulations we've got. And ultimately, yeah, most people don't have it at the moment, but say it's not easy to determine whether something's been damaged because of that, because say you're not talking about a big black mark and flames coming out the back of your TV. Most of the time it's just something that doesn't work anymore for some reason. And hopefully in the future, if we get say a whole street and half the houses have surge protection and half didn't, if the half of the street's equipment fails rather often and the half doesn't, well, there's your evidence as to why it's actually needed. And certainly for domestic, you're not looking at a huge cost to put it in. It's sort of £50, £100, depending on manufacturer you buy from. And even if that saves you one television from being busted, well worth it.
Yeah, no, I can't. One of the things probably people maybe hasn't been explained enough is 443.5, the risk assessment method for surge protection. Calculated risk level is used to determine if protection against overvoltage is required, but it's only of an atmospheric origin, not necessarily strikes and strokes. So people need to realise that this risk assessment, if you're heading into it, and in the current regulations, then maybe you've kind of misread or not interpreted the black and white of what we need to do. And it's also nice to see that the industry is now coming across with a common message that overcurrent protection devices are required for the surge protection devices, because they do form a bit of cabling, and most of the manufacturer's instructions require it. I believe there are some SPDs that don't, but you need to get specific instructions for it. But anyway, we're not on surge protection yet. We'll get onto that. Yeah. We've digressed. Should we go into part 3?
Yeah, part 3. I mean, there are some of the definitions in part 2, but we'll look at those again later because they fit in with other things which make a bit more sense. We'll have a look later. Now, part 3 isn't particularly large anyway, and in terms of the changes, there's actually very little, in fact, at all. So it's really only one item.
It is, yeah, literally one.
Which is 301.1, and the bit that's been added is that these characteristics will be taken into account in the choice of methods of protection for safety, isolation, switching, and the selection and erection of equipment. That's assessment of general characteristics.
Yeah, no, that's pretty much about it, folks. So number 3, for some weird reason, I don't know. Number 3, just I'm waiting for Amendment 3. I think Amendment 3 of the 19th edition. There's going to be some groundbreaking changes. When I say groundbreaking, I don't mean shock horror, but I just mean some of the fundamental principles are going to get rewritten to just normalize what the changes, the transition we're going through. Because I've said this before, many an event, when we were training, or the fundamental principles we're taught in college is it's generated, it's transmitted, it's distributed, it's stepped down, it's put into a home. We then protect against thermal and magnetic issues that could occur. We're now protecting against overvoltages, we protect against earth leakage, but we always had a resistive or inductive load on the end. Now we have electronics that chop up sine waves. We've now got backfeeding supplies, we've now got battery storage. The way that we think, the way that we do electrical installations is changing, which does have an impact on the grid, because most installations now produce harmonics. So we're going to have to change and emerge and develop as a trade the way we think about selection and erection. This is what makes it quite an exciting time, because there's just so much learning and rethinking and reevaluating of how our normal thought processes work to adapt. So there you go. Right, part 4. First one. So big change. No, not massive change. The regulation for protective equipotential bonding. It's changed ever so slightly. It used to say in each installation, main protective bond conductors complying with Chapter 54 shall connect to the main earthing terminal extraneous conductive parts, including the following. Then it listed them out. It now says in each building, which is a change. And then it says incoming and outgoing metallic parts which are liable to introduce a dangerous potential difference and do not form part of the installation shall be connected to the main earthing terminal by protective bonding conductors, examples of which may include. I really like that rewording. That, for the first time, has explained it far better.
Yeah, this particular bit has always been a bit of a dog's dinner, really, in terms of what to actually bond and what not.
Oh,
so,
John, don't hold back.
Quite an impressive change there. So it is
a good change.
Yeah, I mean, the actual intent of it is basically the same, but it's just written in a much better way, and it gives some examples of what metallic parts include as well. So metallic water pipes, gas pipes, and other metallic installation pipework conducting, central heating and air conditioning systems, and exposed metallic structural parts of the building. And of course, there may be others as well. And a nice bit they've deleted. There used to be a bit that said metallic pipes entering the building having an insulating section at their point of entry, as in a plastic bit. You need not be to connect to protective equipotential bonding. That has gone away. And now it says where non-metallic pipes, for example plastic, enter the building and are then connected to metallic pipes within the building, the metallic pipes within the building do not require protective bonding. So it's the pipe coming in which matters now, not the fact that there might be a bit of plastic put in a particular section somewhere.
Now, John, we actually recorded a podcast on bonding itself, because part of this series, other than having some amazing ladies on this series, we've had a number of earthing podcasts out now, and we've also got bonding and a few other bits and bobs weaved into that technical thread. I've always been I've never liked that line about where non-metallic pipes enter in the building or metallic pipes enter the building need not be bonded, because that immediately says just don't bother thinking about it if it's plastic, but yet don't think about or consider the journey that the pipe goes on. I think there was a great example on social media where it was Gary at GSH. He had a gas pipe and it went out of the box and it was insulated insert, but then it went down into the ground and under the floor and back into the house, which would then make it bondable. But if you took it in a blinkered view, you may say, no, it doesn't require bonding.
Yeah, this is quite a common situation in certainly older properties where you've got, like, I mean, I live here and it's got a plastic water main that comes in, but then the pipes within the building are copper. And crucially, in certain areas, like in the kitchen, the bathroom, those copper pipes go in the concrete floor and then come out somewhere else. So although it's a plastic one coming in, they then go in the concrete in several places, and therefore they are and do need bonding and are bonded. So it's not just about saying, is there a bit of plastic in the pipe, or is there a bit of plastic pipe here? It's where that pipe goes throughout the whole building. So
I was going to ask you if they were bonded, but you beat me to it. So yeah, I mean, it's a little bit of a rewrite there, isn't it, really? Is it a bad thing? No. One of the reasons why, and I'm just going to say it, and please don't mean to cause an offence to anyone. One of the reasons why I think these regulations are being reworded, maybe I think it's a good thing. The reason being is I think everybody in this industry, in my personal experience, operates a slightly different frequency or a different thought process, and we're all at different points of the learning journey, John. So, for instance, if you're an apprentice trying to understand what an equipotential zone is, I found the best way of teaching an apprentice what an equipotential zone is, change the word equipotential to equal voltage. And you just say everything that's metal or conduct should be at an equal voltage under fault. And then it kind of, the penny drops and they get it. Now, the regulations have never done anyone a favour with the way they're worded. So I'm a big fan of clear English, plain English. And this is why I've always said that Sparks should have a say on this document, not in the current broken standards online system it's in, but there should be a form of veto or understanding, because there are lots of electricians at different levels of their learning journey and their understanding that should be able to say, I don't get that, or what does that mean? We need to do a little bit better, I think, is the point I'm trying to make, really, to encompass everybody, to be more inclusive for the knowledge that we have to gain, is my point.
Yeah, the whole concept of exponential bonding is actually pretty simple. Unfortunately, it's quite easy to make it into a big tangled mess and sort of deviate away from the original intent of it. So it's certainly an improvement. Is it the best it can be? Probably not, but it's certainly going in the right direction. So
the thing is, John, you're absolutely right. It is pretty simple, but I will confess, when I first learnt equipotential bonding, it was a mess for me. I did not understand it. I didn't get it. And it was only after one of my tutors in college, and literally in the last few weeks, literally just sat me down and said, stop being an idiot. It's this, it's this. And then once you understood it was all equal voltages, you create an upside down pyramid. And at the bottom of the pyramid, you have the earthing conductor. Each pyramid is an electrical installation with one supply. At the bottom was an earthing conductor. Yeah, and the layer then it's an earthed bar or an earth terminal. From that, you'll then have equipotential bonds and CPCs. And if you use the correct terminology and you understood that an earthing conductor connects the fixed installation to the general mass of earth, and a bonding conductor connects extraneous metalwork to the fixed installation, and CPCs are individual circuits for carrying fault current and also equipotential bonding, you kind of then get it. You start to get it. You map out the configuration. We're really bad at that. But please listen to our earthing podcasts for more on that, and hopefully it'll all make sense. AFDDs, John.
Yeah, that's the next big one. I mean, there are a number of other minor piffling changes, like they've changed the word and removed full stop and things. But
how dare
the
they?
next big
How
thing
dare you?
is AFDDs, or arc fault detection devices. Now, at the moment, these are just recommended as providing additional protection, and there's a list of various places which basically encompasses everything, like sleeping accommodation. So that's every home in Britain.
We should read it out, John, because remember, this is an audio podcast as well as YouTube. So yeah, I'll read out the existing reg. Arc fault detection conforming to BSEN 62606. So guys, whoever does inspection and testing, you know 60898, you know 61008, 61009, 62606 is another one you need to slot into the mental toolbox as being able to call it off the top of your head. Are recommended as a means of providing additional protection, recommended being the key word, against fire by arc faults and AC final circuits. Examples are premises with sleeping accommodation. Yeah, okay, define that.
Basically,
it's everywhere. Locations of risk of fire due to the nature of materials, fair enough. Storerooms, then goes into woodworking shops, fair enough. Stores of combustible materials, I thought RCDs did that anyway. Locations with combustible constructional materials, fire propagating structures, CBT locations, look at your external influences, Appendix 5, and locations with endangering or irreplaceable goods. I look at that as museums and zoos. That's how I see that last line now. So that's been changed. And what's it been changed to, John?
Right, well, instead of being recommended, we've now got, assuming this goes through, is arc fault detection devices conforming to BSEN 62606 shall be provided for single-phase AC circuits supplying stock outlets and fixed current using equipment with a rated current not exceeding 32 amps. So shall means you will fit them in, and it's no longer an optional thing. And they're still recommending them for all other circuits. So, but bearing in mind they only go up to 40 amps anyhow, that's not actually much else. However, you can omit them where unexpected disconnection of the circuit could cause danger, and there's some examples here which are unfortunately quite meaningless in the terms of AFTDs, because AFTDs are primarily aimed at the domestic kind of market, and the examples I've given where you don't need them are exciter circuits of a rotating machine, a supply circuit for a lifting magnet, a circuit supplying a fire extinguishing device, circuit supplying safety services such as fire alarm or gas alarm, circuit supplying medical equipment used for life support in specific medical locations, and lighting circuits in dwellings. So in terms of your typical house, you don't need them on the lighting circuit, but you most certainly will need them on the sockets, and you'll probably need them on things like your cooker circuit and your immersion heater, and bizarrely, probably not your electric shower, because that's normally going to be above 32.
Yeah, well, yeah, my electric, yeah, definitely. So anything over 32 amp not needed. We kind of predicted that last November, and we knew that before that. And then lighting circuits, because you're not going to use the minimum required. So for those who are wondering, AFDDs, just a quick one, they were designed, they originate kind of in the 70s. They're known as arc fault circuit interrupters in America, but don't confuse these with the American ones. The American ones are totally different. When they arrived in Europe, they were fundamentally redesigned because the voltages are different and the electrical systems are different. These ones effectively have small computers or microprocessors built into them with functional LEDs that light up and tell you the state at all times, pretty much. And what they do is they analyze the sine wave, which is the wiggly thing that we learned in college many years ago, and they look at noise and disruption on that sine wave, and they are able to tell whether the disruption is an arc, which could cause harm or a fire and interrupt the supply. Now, under the standard 62606, anything below 2.5 amps is deemed an arc, although the Wilex Electrium Siemens one works at anything from 1.5 amps, as the manufacturers have stated. Even so, my lighting circuit uses 60 watts. So
yeah, this is
pointless.
probably why it's there, because the most common type of arc, there's two types of arc. You can have a series arc and a parallel arc. The most common by far is a series arc, which is where you have a break in a single conductor, so either line or the neutral, and it's arcing between the ends. Problem on a lighting circuit, it's all going to be LEDs these days. Current flow is going to be minute, in the region of sort of less than half an amp, and if you have a break in a conductor with only about half an amp of load on it, it's simply not going to create an arc of the required magnitude that's going to be a danger, and these devices simply won't detect that. In theory, if you had a parallel arc on a lighting circuit, as in between your line and neutral or between the line and the earth, that could be detected by an arc fault device. The problem with that is that if it's between the line and earth, it's going to be picked up by the RCD anyway, and if it's between the line and neutral, how likely is it you're going to get an arc in the sort of region of several amps, which doesn't go full short circuit and trip your 6 amp circuit breaker anyway?
Yeah, you're pretty much not, John, are you, really,
So
to be honest with you?
Really unlikely. There's probably some weird, bizarre set of circumstances where it could be an arc of like 8
John,
amps or something. But
I measured, I have a radial to each room in my house, because that's how I've wired for over 10 years now, radials to each room. That way I can switch off. I have the functionality of switching off each room as and when I choose to. My radial with my television and my Apple TV and my Xbox and all the other bits and bobs, I worked out that I use less than an amp. It's got a 20 amp breaker on it. So do I need AFDD? No.
Not really. No. It's really, say, unless you've got 2-3 amps on your circuit, then probably not.
So, John, this again leads us to, and this is an advisory, because I don't know if I agree with the shall or not, because the shall infers you must do it, and that's a load of crock. You should be able to select and erect it suitable for the required protection. I definitely think arc fault has its place. Without a shadow of a doubt, it has its place. I don't know whether I would have this in my house on anything other than maybe my cooker. I've got a 32 amp cooker circuit, electric cooker supply, maybe an immersion. But do I use the immersion that much actually to warrant it? It's again, it's proportionate. I think we're going to end up having to work out what the loadings are on these installations and the leakage, which we'll cover in a minute, to make sure that we're actually providing adequate protection. But it's worth noting as well, these devices use power. Okay, so this is a hidden cost of ownership now. Okay, because those little LEDs that are operating, if you go out and buy a 10-way board for your customer, let's say it costs you, I don't know, £1,000 for the board, because the cost is coming down. The cost of running those little microprocessors, they will consume energy. Those LED lights will consume energy. Now, not much, but over a year, if you work out the total cost of ownership, just running costs of the boards, you're coming into the potential hundreds of pounds. Over 10, 20, 30 years of life, you're looking at potentially thousands of pounds, the lower end of thousands of pounds, but still a rather large chunk of money just to own the board and run the microprocessors. Now, hark, I hear people screaming, yes, but the fire safety benefits. Okay, virtually everything in my house is low energy now. I've just removed my immersion heater. The only thing I can really protect is my cooker.
Yeah, I can see these being. I can see the validity if I'm, say, in your kitchen, because most kitchens are going to have some fairly high-powered stuff there, like your washing machine and your dishwasher, and
that was what I was going to say next.
Tumble dryers and that sort of thing. But if you look at everything else in your house, TVs are now like 50 watts, 70 watts maybe.
Yep.
They're just not high consumption devices anymore.
No, they're not at all. There's nothing to it. But yeah, I agree. So for me, arc fault detection, I would suggest that regulation where it says conforming to 62606 should be provided for all fixed equipment in kitchens, including washing machines, dishwashers, tumble dryers, and cookers, not exceeding 32 amps. Yeah. That would be a better wording, I think, or there or thereabouts.
But yeah, it comes down to white goods things, basically.
Did you know, John, and I'm sure you did, that the committee that wrote the standard is made up of white goods manufacturers?
Yes, it is.
You can see why that these devices have been made, and it's probably easier to put one in the fuse box and make the customer pay for it than it is for the manufacturers of the white goods to put something into the field equipment.
Definitely. I mean, if you're looking at, at the moment, AFDDs are still in the £100 plus range. And if you go and buy a washing machine from the cheap end of the market, you're looking about 200 quid. So the realities of adding £100 onto a washing machine, not going to happen, are they? So
no, they're not at all. Right. So I think we've covered AFDDs. John, what do you think? Do you think we should be commenting on it? Do you think we should be saying?
Well, yes, I think we should, because in some areas, putting shall is going to be fine. If it said shall be provided for kitchen equipment or something like that, but saying all socket outlets is a bit of a fail, really, because if you look at a house and even a small commercial installation, vast amounts of the stuff that's going to be plugged into socket outlets is really, really low powered stuff, and there's no way you're going to get arcs on that unless you get the highly unlikely parallel arc between the line and neutral, and it doesn't put enough current through there to cause it to trip the overcurrent device anyway, which is possible, but it's exceptionally unlikely. Well,
given the fact that the majority of these AFDDs include RCBO technology, very, very unlikely to be an arc related trip, isn't it, really?
Yeah, it's series arcs is the vast majority of that type of fault. Which, if you've only got 3 amps or something above, then that's fine. But for a single item or even a few bits of equipment, it's unlikely to ever get there. So yeah, just blanketly shoving it in on all socket outlets is not really the route we want to be going into.
Okay, so we're moving on, and this will be our last one we cover before we break for a mo. Right, 422.1, and it's chapter 422, precautions where particular risks of fire exists. Now, in the current regulation, it says the requirements of this regulation should be applied in addition to 421 for installations. 421 was about arc fault. For installations in locations where any of the conditions of external influence exist. So it then talks about wiring except for wiring systems meeting the requirement, and it just goes off on waffle. They've now completely pretty much reworded this, where they've now said in such locations, so they've added to 422.1, and they've said in such locations the fire safety design of the building or buildings should be documented. This is a good thing, because you and I both know if you ever ask anyone for their records, O&Ms, manuals, drawings, you generally get a blank face, whereas we need to break that shift, and people need to be able to go, welcome to my home or my building, here is my records.
Yeah, this is something which should have been in place decades ago, really.
CDM of 1994 required it, John.
Yeah. So unfortunately, though, it in the real world rarely seen.
Well, yeah, and the trouble is, when you say real world, it's required. The trouble is the contractors that were doing the work wouldn't produce it, because at the end of the job, everyone knocks their pipe out to get the job finished. You open something or you do something where it's completed, and then the records just handed over and nobody checks them. They just get chucked in a drawer or left on a desk, or they don't know what to do with it. So that's a cultural issue, I think, really, to be honest with you. It then says this information should be included in a fire safety manual produced by or for the person responsible for the building, the responsible person. And the responsible person, by the way, is defined in the Regulatory Reform Order for Fire Safety Act of 2005. It's a piece of secondary legislation. Now, the fire safety manual for a building, that's an interesting one, because that could just be a building. If you're going to a tower block in London, that could just be the building manual of all the data for everything, all their brochures, catalogues. Fire safety risk assessment is one of the key documents. If you're working outside of your domestic, if you go to a tower block, you should be able to get a fire risk assessment, because they've been required since 2005. And it then talks about, as detailed national legislation, it references for the first time outside of the exemptions BS 9999, which you can see the fire engineers are obsessed with getting 9999. And if you look around that number of British standards, it's all to do with fire safety. So 9992 is fire for railways, brand new standard released this year, 2020. It then says the electrical system designer / installer shall provide the person responsible for the building with details of the electrical system, setting out the basis of the design respects to fire safety. It shall explain the operation of associated relevant building services and give information on routine testing and maintenance. Now, John, if I live in a flat and the flat's mine, does that mean I then have to get a design done? And I'm talking about documented design, and hand that to the landlord for him to check it?
It might. Because if you're in a shared building with, say, 100 apartments, what you do in one can easily affect other people.
Because you may have a 99-year lease on that building. It's yours, but 99-year lease still requires the landlord to see it. So if you're a domestic installer, dwelling installer, as it may be, so I love that term, it's great. There's so much banter in there, it's mind-blowing. If you're that, then rather than doing the selection and erection in your head, we may now find domestic installers having to document and define their designs, which I don't see as a bad thing, actually, to be honest with you. It then moves on. Again, this is all theory. It's down to you guys to comment. Where it is determined that cables shall have an improved fire performance, but are not covered by 4226. This may be achieved by cables with a minimum light transmittance of 60% when tested in accordance with BSEN 61034-2 and of limited flame propagation according to minimum requirements of BSEN 60332-3, or where cable management systems according to 42221 are used and cables to minimum requirements of 60332-1-2. I'm all numbered out. John, what does that mean in English?
Yeah, basically this the 60% thing is a test that's done on cables in a particular standard. So they're basically set on fire. When the smoke comes off, the smoke's measured to see how much light goes through. What this really means in reality is that if you're going to put stuff in, then it's got to meet certain standards, and it shouldn't start melting and giving off toxic fumes and billows of smoke and whatever else. And most importantly there, cable management systems shouldn't do this either. So things like plastic mini trunking made out of PVC, probably not going to comply with any of this. Because if you burn PVC, it makes the most horrendous mess and black smoke and toxic gases, hydrogen chloride and all that. So sticking up your mini trunking and putting cables in it in these types of locations, probably not going to be allowed anymore.
Now, John, I don't think this will ever make it, and I'll tell you why. Because my background's mainly predominantly industrial, where it was all steel conduit, which I liked because it was robust, and the general public, the layman, couldn't touch it or hopefully not be injured by it. Plastic trunking, when I was in my younger years and we were doing house rewires, I remember councils doing rewires of old buildings where the whole thing was surface. And I'm talking about YT2, YT3 across kitchen ceilings, everything surface. So you had an old house that was wired in maybe 3/4 inch imperial conduit, and rather than pulling cables through it again, they just went, sod it, we're just going to do the entire rewire with a bit of maybe MT3 around the room and then just all MT2 drops. So whole houses have been done with sticky back trunking. Never liked it. I thought it was just really lazy, really poor. I understand there was a use for it now and again, but I think it's just become too common. So I think this regulation is going to be very hard to implement, and I think there'll be a lot of confusion over its implementation. I agree with you. I think this means the death of YT2. But one thing we should probably say is that regulation for 22.2 very specifically covers protected escape routes. It also goes on to say cables or other electrical equipment shall not be installed in a protected escape route like that unless they're part of an essential fire safety or fire related safety system. It then says generally this means, I hate that word generally, this means cables in a protected escape route should be limited to lighting, emergency lighting, fire detection and alarm, so no submains folks, although cables for other safety systems may be necessary. Now, if you were going to have submains, you're going to probably look at fire-rated FP400s, you know, boxing it in, having it in its own compartment, that sort of stuff. At the moment, yeah, looks like the death of YT2.
Yeah, the things like submains, indecently designed blocks of flats, they'll be in riser cabinets anyway, which are generally fire-resistant doors and all that stuff, and should be locked at all times and all the usual stuff, which may or may not happen. But yeah, sticking bits of plastic trunking across the ceiling in the shared areas of the hallways and whatever, which happens a lot, should be going away if this goes in.
Well, again, this is definitely why we want people to comment, but it does carry on because it's quite an extensive bit of rewriting here. It says cables in escape routes shall be short as practicable. Cables encroaching on escape routes shall not be installed within arm's reach unless they're provided with protection against mechanical damage likely to occur during evacuation. Where used, cable management systems shall be more than one of the following types, shall be of limited smoke production. PVC is not limited smoke production. It then says conduit system classified as non-flame propagating, cable trunking and cable ducting classified as non-flame propagating, and cable tray and cable ladder classified as non-propagating. PVC trunking doesn't exist anywhere in that.
No. Basically, all that stuff as non-flame propagating comes down to being made of steel. And that's your choice, because plastic trunking or plastic conduit or whatever, if you set fire to it, it makes the most horrendous mess and thick black smoke and toxic fumes. So exactly the one things you would not want in an escape route.
Yeah, I think if this does come in, which I hope it does, because you know me, I'm fire friendly. I think this is a good regulation. I think this will require a lot of guys to dust off their rust, and the guys who may be new to the industry to invest in some metal containment installation skills. I wouldn't be surprised if some short courses appear to help enhance people's conduit and trunking installing skills. In all fairness, you've only got to go on the likes of GSH's channel to see how to do it, and they do full breakdowns and how, some really good knowledge about already to teach you and remind you of how to do it.
You know, I like steel conduit. I almost never do it because I only do domestic stuff, and of course it's pretty much never used because it's very expensive. And
I think you need to go out and buy a set of benders, mate. You need to go
out
and get a vice bender. Oh,
yeah,
have you? Oh, good man.
I've got all the stuff to do it, but say it's rare that I ever use any of it, because if you quote some domestic place, say, "Oh, do this in steel conduit, looks lovely," and all that, and then someone else comes along and quotes it for a quarter of the price, well,
a bit of twin and earth clipped outside, and you're doing it in tube. Yeah, I know. This is one of the problems. of the changes in the regulations is the impact to the competent and responsible installers. It's a challenging thing. John, what I'm going to do, I'm going to pause this here and we're going to end this because obviously there's still lots to go through, and we want guys to be able to get out their vans and go to work and earn their day's pay for their families. So we'll end it here and we'll pick it up on a part 2. Any final thoughts for this section we've gone through so far?
No, I think it's interesting changes, so we say, but all remains to be seen as to exactly what actually ends up in the final version, which could change at any time.
I totally agree. Right, guys, girls, thank you very much for listening. Thank you very much for watching. You know by now where to find us on YouTube, whether it be Sparky Ninja, E5, John, and all the other people that try and share their knowledge with you, which is great. And until the next one, which will probably be very soon, actually, because this will be a series of them. That's it. Take care of yourself and each other. Bye-bye.
Bye.